Alright, so here's the schematics. We'll go through a quick rundown of the schematics. Start off with the voltage regulator. So this is a voltage regulator. It takes in 5 volts from USB, and so linear LDO, it regulates down to 3.3. I've got jumpers here that you can jumper in power from here, because I've also got the option to jumper in power from the USB module, because in these MSPs they can provide 3.3 through the USB controller, but it's a little more current limited than this module, or this regulator. This is a 1/2 amp regulator, and since I want to be able to support, a plug-in card, and I don't know what that might be, I want it to have a decent amount of current. So you can do either or, but I would probably go with that one most of the time. Over here is the bootstrap loader button. It's got a pulls up the PUR pin high. You can see over here to enable a bootstrap loader. When this is open, this is really weakly pulled down to ground, so BSL is inactive. Here's the USB connector with the 2 inline resistors for D plus and D minus, your differential data signals. Ground and power, 5 volt power goes into V bus here. You can see this VUSB, that's a 3.3 USB or 3.3 voltage from the USB module. This is my crystal oscillator that I need for the USB controller. It's 4 megahertz, and it's got a PLL. I just picked 4 megahertz because it's pretty common. Down here you've got the 2-wire programming header, JTAG header, master clear button right there, and the cap and resistor that are for in fact that needs to be changed to a 1 nanofarad. And that's the cap resistor combo for the master clear pin. And so we zoom out, you can see the top and bottom. There's the 230 pin expansion headers. That's pretty much all that's down here. Digital I/O from the MCU, and then power and ground. So same thing up top, I/O from the MCU, power and ground. Here's J5. This is the other expansion header that's down below. It's a 2 row 6 pin. It's on each row, total of 12 pin expansion header on the bottom right, and that's all extra I/O as well. 8 LEDs right here for just digital I/O and indication. Access to J3 through or access to pin 29 LCD cap R33 through J3, and the V-core cap, that just comes right out of the data sheet, and then the pull-up 10K pull-up for another digital I/O to play with a push button. And so this is just basic user functionality. This is really meant to support a lot more complex hardware on cards, but you can never go wrong with LEDs and a button. And that's pretty much the whole thing. This design is really for a bare bones development board for a USB based high pin count MSP microcontroller. A lot of horsepower in a small package, and a lot of expandability. And so if we move over to the layout, we can match this up. In the center you've got the MCU. On either side here you've got the 30 pin expansion headers. J5 is that extra expansion header right here, and down here you've got your LEDs. These are all LEDs. Up above those are the resistors, the current limiting resistors for those. You've got your push button here, user I/O, J3 jumper, J3 jumper, J2, J1 for the those are the jumpers for the voltage regulator. 2 programming headers right here. Your bootstrap loader push button, master reset, and this is a crystal oscillator for USB. So that's pretty much the whole design. The layout's kind of tight when we put our planes in. This is a 2-layer board, and this saves a lot of money when you do the layout and then do a copper pour and try to lay it out such that your power plane and ground plane can also be on signal layers, and that's what this is. Top VCC and bottom's ground, and my traces are still on top and bottom, but it's laid out in such a way that the copper pores can get in and out of everywhere they need to go. So that really knocks the cost down quite a bit. Up here you've got the USB connector right there, and the 2 resistors in line for USB, and so these are parallel signals you really want to run in parallel. You want to make sure they're pretty much the same length all the way to the processor, but that's pretty much it. Should be a solid, robust platform to develop on, and I'll try to get some more videos out, but this has already been designed and developed, and so this is actually being built up right now up in Chicago at a board house. So I should get some fully built units to test. There's a couple fixes. I'll go over the fixes. I made a couple mistakes, but I'll save that for another video. I'll go over those a little bit later. But I just wanted to give you a brief rundown on the schematics and layout. I'll have the pinouts up on the website. It won't be a final PDF, but over here, this is kind of a pin breakout file, so you can look and see what pins on the headers, expansion headers, go to what pins on the MCU, and I've almost finalized what MCUs I wanna support. And I think it's gonna be the mid 5X series, but once I pick those, I'll finish this up and have a fully populated tables. But it kind of gives you an idea of where I'm going in the development process, and I try to keep a little documentation going along at the same time, just so I don't get confused. So this is the last video, or the first video after my Kickstarter. I figure I'll put this information up online and see if anybody's interested in it, because it seemed like there was some interest in my Kickstarter. So right now I'm at the first rev kind of prototype stage, and so hopefully I can start developing some embedded firmware pretty soon once that hardware comes in. Any questions, feel free to contact me, and if you have any interest in this, let me know. I'd definitely like to know if there's some interest in distributors for a development board like this. So until next time,